Gosh, I think probably discovering structures, protein structures. So there are two exciting things that we were involved in. The first was the structure of a complex, which is really important for signaling in plant immunity. And that laid the foundation for much work subsequently and understanding of how plant immunity works, at least, one branch of plant immunity. So that was in 2013. So that was the EDS1 cyclin 1 complex that we resolved together with a colleague at the University of Cologne, Carsten Niefin. And then the second, probably, most to my mind, incredible thing is what we've just published, actually, which is work together with Gigi Chai's group. So Gigi Chai is a superb protein structural chemist. Again, it's we do genetics, and then structural chemistry is important to kind of understand the nuts and bolts of a system. And so there we just recently published 2 papers together where we found a long sought after link, small molecule second messenger link between receptors that recognize pathogen molecules and then the downstream signaling. So that was an important thing in the field to discover, and Gigi's structural work just showed it so exquisitely that I'm still kind of excited thinking about it. That's a really good question, because I think scientific research has changed so much over the time that I've been researching, which is, I don't even want to think about how long I've been. But before you could perhaps accomplish, as a PhD student or a postdoc, you could accomplish something without reaching out to other colleagues. I think now it's almost impossible to do that without collaboration. And actually collaboration makes it all the more interesting. So I think that's a good point that, so for example, in our work, I'm a geneticist. I do genetic dissection, and I make mutants, and I look at phenotypes. But combining that with structural chemistry has been, the added value of that is enormous. So I think it's really good. I think it's really important to be open to form collaborations if there's a particular thing that you want to do that you can't do yourself. Infrastructure is important. It's not the defining thing. I think the ideas and how you conceptually identify what are important questions to ask, it's very important. But still, then you have to have the infrastructure to be able to do experiments. And here at the Max Planck, I'm very privileged in that there's really no limit to what we can do or we can reach out to collaborators, as we've discussed. So that's one element it just helps you move things along. Another element I think is incredibly important is the personalities that you have in your group, and they, the way that they gel and the way that they help each other and strengthen sort of cohesion between young scientists and feeling that they are helping each other is very important. It doesn't always work, but most of the time, and especially in COVID, my goodness, it's been incredibly important, the supportive network between young scientists, because some of them haven't been able to go home. Asian scientists haven't been able to go back to Asia. It's been tough for them. So I think that's emphasized the need for this support network. I would say, and in fact, I when I interview young scientists, I say that actually I'm not looking for you to have a sort of massive knowledge of everything, because none of us have that, but what I'm looking for is a passion, a curiosity, that is the driver. It gets you up in the morning. And if you don't have that, You should not be doing research. I mean, I think that's it would be cruel to make you do research if you don't have that inner, I call it an engine, that's, it's, and you really know whether it's there or it's not. And actually, I've learned through hard experience that if a student is not self-driven, self-motivated, and eager to do, to push things forward, then it won't happen. Again, it's a kind of it's something that I suppose every researcher thinks about. It's my own personal feeling, but I don't have the pressure that I know colleagues abroad, in certain countries have. I'm in a privileged situation, but I think very seriously that it's quality over quantity. And I would much prefer a student or a postdoc to publish one quality paper than try and get 3 out or 4 out or whatever. So numbers of papers, I think we should be less obsessed by. In fact, I would quite like for the whole field to publish fewer papers. I think that would be, but the flip side of that is that a student or a postdoc, if they're ambitious, they want to have a paper. So you have to balance those two kind of requirements. Again, it goes back to this collaboration. So quite often, and in these latest papers that we publish, it's big collaboration, lots and lots of people who are contributing to that work, and that's all of them should be recognized for their contributions. But sometimes your student will want the first author paper, and it's a tough one. But I don't think any researcher, at least from my experience, resolves that conflict because for every paper you have to make a decision. Well, when do we stop? Where's the cutoff? And that's always a difficult decision, or do we spend another year, So I think every research group has that issue. It's not a simple one. And of course, it's to some extent decided by what the student or the postdoc wants out of it. I think it's not a bad idea. So, I mean, of course, you've got to balance it, because you don't want the paper to be so chaotic or incomplete that it's going to be just trashed by the reviewers. You don't want that. But on the other hand, it's quite good to send a paper in and not spend so long, crossing the T's and dotting the I's, because you'll get really good, if a reviewer is doing his or her job, it'll be a good feedback. I mean, I'm going to say something very kind of, it's a bit, what's the word, of a cliche, but I do believe it truly, is that doing fundamental research, I mean, history tells us that fundamental research is the driver of innovation. You just look through history and what are the major breakthroughs. So you have to have that going hand in hand with technology innovation. And if we can get that balance right, then that's a fantastic thing for society. But maybe we need to explain stuff better. I'm at fault there. Because a lot of the population are not necessarily interested in science, but actually quite a few of them, because there are a lot of radio programs and a lot of people who are not scientists themselves are interested in what's going on, and maybe we need to explain things better. So I think it's absolutely, society will not thrive without us.